questions are all paper 1, so we can't use a calculator. So it's a functions question. Number 1a has g of f, which indicates that f is going into g. So function g is x plus 3. So if we're doing g of 7 minus 2x, that means that we're going to have 7 minus 2x plus 3. Joining like terms, that's 10 minus 2x. B, find the inverse function. That's what this means, the inverse, because it's minus 1, not dash. Don't get confused with those. So to do that, we initially write y equals x plus 3, switch the x and y variables, and then make y the subject. So inverse function is just x minus 3. Find f o g minus 1, 5. Now, because they've asked you to stick a value in, and we already have an expression for g minus 1, it's much easier to actually substitute that value into the expression rather than find the general form of it. So first of all, we're going to find g minus 1, 5. So that would be 5 minus 3. And then we're going to stick that number into f. So we're going to find f2. And f is 7 minus 2x. 7 minus 2 lots of 2. There we go. Next one again, paper 1. So solve the equation 2 cos x equals sine 2x. So here, because we have sine 2x, we're going to need our formula booklets to help us out here. Okay, so I can't find my booklet, but I've got this, which is what you're given on the exam. So as we can see here, we've got sine 2x. We've got an identity here for sine 2 theta, so we're going to change that expression there. So we're going to rewrite 2 cos x equals 2 sine x cos x. Okay, I'm now going to rearrange so it's all on the same side. So 2 cos x minus 2 sine x cos x equals 0. We can see that we've got 2 cos x. It's common to both terms, so I'm going to factorise. Get left with 1 minus sine x. And that's because the expression is equal to 0, it means that either 2 cos x equals 0 or 1 minus sine x equals 0. Well, if cos x, 2 cos x equals 0, then cos x equals 0, and this would be sine x equals 1. Now it's on a non-calc paper, and my suggestion has always been to remember what the graphs look like. So I'm going to quickly sketch. So the sine curve and the cos curve. What we do need to do is check the range of values we're looking at. So obviously we're in radians because it's in terms of pi. So this would be pi over 2, pi, 3 pi over 2, and 2 pi. But we do need to keep going to 5 pi over 2 and 3 pi. Two more here. Okay, so this was our sine, and this is our cosine. We're trying to find what cos x is equal to 0, so that is here, here, and here. So they are pi over 2, 3 pi over 2 and 5 pi over 2. And where is sine x equal to 1? So that's here and here. So that's pi over 2 and 5 pi over 2. Obviously we don't need to repeat these values. So our final answer is x equals pi over 2, 3 pi over 2 and 5 pi over 2. Okay, so we're looking at where we have two equal roots. So that indicates we're looking at the discriminant. And the discriminant of a quadratic expression is given by b squared minus 4ac. So a in this case is 2k, b is negative 4k, and c is 1. So b squared minus 4ac, don't put brackets when we're doing this. And oh, apologies, when it has two equal roots, we know that the discriminant from two equal roots, we know that b squared minus 4ac equals 0. It's worth making these statements. It is worth 5 marks total, so you may well get something for writing that. Lots of people, when it comes to the exam, forget to write this part when it comes to doing the working. So please don't do that, because if you are missing it, you probably won't get any marks. So b squared, so it's negative 4k squared minus 4 times a times c equals 0. As I said, don't forget the brackets, because we're squaring the whole term, not just k. So this becomes, this becomes 16k squared minus 8k equals 0. It's in the form of a quadratic in terms of k, so I'm going to factorize. Is equal to 0, either 8k equals 0 or 2k minus 1 equals 0. It's k 0, 2k equals 1, k equals 1/2. So double check up at the top. It does specifically say that k cannot equal 0, which means that k equals 1/2. The line y intersects the graph of f to find all possible values of p. Okay, so we're now looking at the kind of graph it is. We know it's a parabola, and we also know the value of k, so we're going to stick that in. So we've got k equals 1/2, so fx equals 2k x squared minus 4kx plus 1. So that's x squared minus 2x plus 1. The easiest way to identify what this kind of graph looks like is to try and factorize it. So we're finding two numbers that multiply to give positive 1 and add to give negative 2. So then I know those numbers are both negative 1, which means it can be written as x minus 1 all squared. Now this is where we need to remember our transformations of graphs. So this would be a basic parabola, so a basic x squared graph, but shifted 1 unit to the right. So if we were to sketch it, it would be going through positive 1 and look like that. Now they've asked us for the values of y that would intersect the graph. Well, clearly, she hopes it's clear, that if we had any horizontal lines down here, they wouldn't cross the graph. They would only start touching the graph above here. Perhaps I should have used a different colour. In other words, that y has to be greater than or equal to 0.